problem briefly, right? So this is a 2-cylinder engine. It's designed so that the piston are connected to the crankshaft BE. As what I said, we know that this is known as our crankshaft. Using a master rod ABC. Okay, so ABC is the master rod. And as I say, AD is known as the articulated rod. Okay, determine the velocities of the piston C and D at the instant shown. Okay. So what we know is we know that BE is moving at 30 radians per second in the anti-clockwise direction. So immediately write down the information. So we know that omega BE is equal to, I'm going to immediately declare it, minus 30 K radians per second. Okay. So like what I told you before, you have to identify, next thing we do, we have to identify, I'll put a smaller figure by the side so you can see, okay? You have to identify the rigid body. Okay, so we can see there are 3 of them. They are members BE is a rigid body on its own. Then you have BC, and then you have AD. And how we identify rigid body is depending on the what? On the pin. Are we clear? Yes, sir. Oh, you're right. Anti-clockwise. Yeah, I'm having, wait, anti-clockwise positive. You're right. Yes. Yes. Remember ABC. You're right. ABC. I'm messing up today. ABC and member AD. Thank you. Remember to come and get your pint of beer, okay? So how we identify the rigid body is all dependent on what? On the location of the pins, okay? On the pins, right? So we know that BE is a solid piece, ABC is a solid piece on its own, and AD is a solid piece. When that's the case, we can also declare, right? So once we know all this, we know that omega AB, let's focus on member ABC. Okay, because we identify them as its rigid body on its own, we know that omega AB must be equal to omega BC. Okay. So now, let's try to visualize what is going on. Okay. So if you look at how the member BE will rotate, BE will want to make a rotation this way, yes or no? Right? So we will know, okay, we can make an intelligent guess. Do you think that the piston C will go up or down? Make a guess. Down, right? Are you comfortable in down? Okay, because if this arm swing this way, right? If we go this way, this entire structure BC will also want to come down. Okay, so be brave. Be brave. we know that this is your BC. Okay. Now, for that to happen, for it to come down, BC will have to rotate in the clockwise direction. I want you all to take like 10 seconds, breathe and digest. And if you highly oppose, please put up your hand. If you are not sure, put up your hand. If you don't give a shit, put up your hand. Ah, you care. Okay. It's okay. Okay, if you make mistake later on, you'll see the direction will just what? Flip. Are we clear? Okay, but this is what I'm gonna assume. Okay. So we get fixated or we focus on what we want to find. Okay. Okay, let's focus on piston C first. Let's focus on piston C. Okay. So we know that BC, there's a direct correlation, is that we can write that VBC or VB, oh no, VC is equal to VB plus by omega BC cross R point C measured from point B. Okay, we can do that. Maybe later on we can, I don't know whether will it work. It's okay. Yeah, I really don't know where it works. Maybe we can try something different. Yeah, no, that's making an assumption. I don't want to make the assumption. So from here, we have the unknowns. Are your VB and omega BC. Okay. At this moment, you can find your R, your C from point B. Again, you can find your C from point B. Okay, so how about we do that? So we know the distance, so this angle over here, we are aware that this is equal to what? 180 minus 45 minus 60 is equal to 75 degrees. Right? So we have to, now we're going to determine our length BC. Okay, we're going to determine BC. So from here, we know that sine 75 will be equal to 0.25 divided by our length BC. So BC will be equal to 0.25 divided by sine 75, 0.259. After knowing that, then we know that R C from point P is equal to, so both are positive, so 0.259 cos 60 I plus by 0.259 sine 60 J. Okay. So we have allocated, so this is 0.13 plus by sine 60, that's by 259, 0.224. So from here, we have this equation which we will use later. Okay. All right. So the next thing we have to find out, we don't know what is our VB, right? So we can now relate. I'm going to move the figure down. no space. Sorry. I'm going to move the figure here. Sorry for confusing you. Okay. So now we can relate what is going on with VB. Okay, we now have to find VB. And it's pretty straightforward now, right? So we are going to find VB at this instant. Okay, VB at this instant. At this instant means BE is in the what? Vertical position. I repeat again, BE is in the vertical position. So from here, we know that VE or VB is equal to VE plus by omega BE cross R B or B, yep, from point E, right? So we know that VB only have one direction. Okay, so VB at this instance, it only have this direction. So this is our VBI. And it's going towards the left, so it'll be what? Negative. Are we clear? Okay. So VBI will be equal to VE is equal to 0. 30 anti-clockwise is plus by 30 K cross R B from point E. Okay, so from point E, so this is 0.05 J positive. So VBI will be equal to K cross J to be negative, so minus 30 times by 0.05, okay, 30 times by 0.05, 1.5 I. Okay, so we know that VB is equal to minus 1.5 meters per second. Negative means it's correct, it's going towards the where? Going towards the left. Okay, did I make any mistake? Everyone clear down here? Yes. RBE, so this is point E, right? B is on top, so it's positive 0.05. Okay. So from here, we can now substitute into VC. So therefore, VC will be equal to VB plus by omega BC cross RC from point B. So from here, if we look at our VC, okay, so we look at our vector diagram for VC, right? So we say VC is coming down, so there will be a what? There will be a VC minus VC sine 45 minus VC cos 45, right? Sorry, because if I declare this as 45, okay? So from here, you have minus VC sine 45 I minus by, is it sine is 45? Oh, sorry, cos. I don't want to confuse you. Minus by VC sine 45J. And this is equal to minus 1.5 I plus by minus omega BC. Okay, why minus? Because we assume BC to go in a clockwise direction. So multiply by K. And then cross. Okay, cross what? Cross, we just calculated 0.13 I plus by 0.224 J. Okay. So from here, we just do the cos is equal to what? 0.224 707 minus 0.707 VCJ.